Alright, welcome back students. In the previous video we looked at the integral of some e to some x function. We said that we take the e to the x part, the e to the exponential stays the same, we get our plus c. And we have to find our new constant. Well, the new constant is 1 over the derivative of the exponent. So in this case, the derivative of 4x is 1 over 4 e to the 4x plus c. Do not forget your plus c. Let's take a look at some definite integrals of exponential functions. Suppose I had from 0 to 1 the antiderivative of e to the x dx. Well, the antiderivative of e to the x is actually the easiest one. It's just e to the x. The derivative of x is 1 plus c, and then we want to run that from 1 to 0. So that's going to be e to the 1 plus c minus e to the 0 plus c. Again, our plus c's cancel. I'm left with e to the 1 plus e to the 0. Now the thing about exponential functions is we don't like to leave them in this form. Alright, when we have things we can simplify, we need to simplify them. So here, I have an e to the 0, and anything raised to the 0 power is 1. So then this would just equal e to the 1 minus 1. That should be a negative. E to the 1 minus 1, but we don't like to have things to the 1 power, so that's just e minus 1. And that's the antiderivative of e to the x to the first power, from 0 to 1. Let's try another one. Suppose I have negative 1 to 1 of e to the x dx. Well, again, our antiderivative is going to be the same. Just as before, it's still just e to the x plus c from negative 1 to 1. So when we plug that in, we get e to the 1 plus c minus e to the negative 1 plus c. Once more, our plus c's will cancel, and we get e to the 1 minus e to the negative 1. If we want to simplify that, e to the 1 is just e, and e to the negative 1, remember a negative exponent just means it goes in the denominator, is 1 over e. And that would be your simplified solution. So what we want to look out for is we want to look out for negative exponents, turn them into denominators. The reason we're doing this here and not before is because there's no variable over on this value. My e to the negative 1, there's no x here, there's no y's, so we want to turn it into a regular value, the regular value. Just like you wouldn't say 4 to the negative 1, you would write that as 1 over 4. There's no variables, so we want to turn it into a number. The other one you want to look out for is when I have an e to the 0. You never want to leave anything like e to the 0 or 5 to the 0, or whatever value you have, even x to the 0. You always want to immediately just turn that into a 1. It's going to make everything easier. Alright, let's do one more tricky one, and then that should be enough. So let's try one that's a little bit trickier. We've got the integral of 3e to the 2x plus 4 dx. Now this 3 might be tricky, so we're just going to leave it outside for now. We're going to say 3 antiderivative of negative 2 to 2 e to the 2x plus 4 dx. If we do the antiderivative, still going to be 1 over the derivative of the exponent. The derivative of 2x plus 4 is just 2. Now we leave my exponent alone. And then I run that from negative 2 to 2. I dropped my plus c. I think you guys have seen plenty here now of the plus c's just kind of going away. So that'll give me 3 1/2 e to the 2 times 2 plus 4 minus e times 2 times negative 2 plus 4. We're going to simplify that again. Let's make that into 3 halves. E 2 times 2 is 4, plus 4 is 8, minus E 2 times negative 2 is negative 4, plus 4 is 0. Excuse me. So, when we finish running our calculations, again, we don't want to keep anything e to the 0. There's actually a lot of probability parts that have to do with things minus 1 and 1 minus other values. So it's good to see some minus 1s. Now guys, that should be enough to get you through these two assignments. If you have any questions, see me on live chat. Otherwise, good luck.